So we'll go with you to our first chapter. The anatomy consists of two words, ana, which is a prefix, and tomi is a suffix. Tomi is the medical term that stands for cutting, dissection. And ana actually translated in a different way, translated like up, back, which refers to the repetitive action. So it's repetitive dissection that the anatomy deals with. So anatomy deals with the structure, whereas physiology, logi is the study, physio means actually life, is the study of life, study of the function, study of the functions of the living organism. And the kinesiology, as you already studied, that's the mechanics of the body movement. So we're going to deal with you with physiology, even though that's the formal title of this class, but we will have to cover quite a bit of anatomy with you as well. So the science deals with hypothesis at first. Hypothesis is the singular. Hypotheses, when you change I to E, that's going to be plural. So it all starts with the idea, you may say. So the scientists come up with an idea, and then they try to prove that idea with experiments, or to refine that idea with experiments. And so if the experiments support this hypothesis, which like you may call it a guess, then they will call this hypothesis a theory. And the theory is further, as you can see on this slide, and it's in your textbooks as well, that the theory, once it's accepted, if it has unusually high level of confidence, is accepted as law. So basically, the theory and law, they are closely actually connected with each other. Law is usually something that you can measure, right? It's something like, for example, the law of the electrical current. It's proportional to the voltage, and it's a voltage divided by resistance. So that's electrical current. But now, what is electrical current? And that's when you have to come up with the explanation that the electrical current is the movement of the charged particles, whether electrons or ions, or let's say we want to predict the pressure, the amount of pressure in the chamber. And so we can measure the pressure. For example, pressure is increased as the temperature grows, and it decreases when the temperature goes down, as the gas cools down. So we can actually measure the pressure, but what actually makes that pressure? And for that, we have to come up actually with quite a few theories, not just often with one theory that explains to us that the gas is composed of the molecules, and that those molecules, they don't stick to each other, but they kind of repel from each other, and they move chaotically in all directions. So that's why the molecules in a certain chamber, they exert the pressure equally on the walls of the chamber. So we can measure the pressure in it. So basically, in simple words, theory explains certain phenomena, whereas law helps to measure, helps to predict, and so they closely connected, theory and law. So obviously, if the hypothesis was wrong, if, let's say, scientists in different places could not reproduce the experiments, then it's turned down, and they have to refine the hypothesis and redesign it, and go through these experiments again until it comes to a satisfactory explanation. And often, you may have just several theories that are trying to explain certain events, certain phenomena, or certain processes in the body. And they kind of competing with each other without basically taking completely over. And the scientists, they just choose, okay, I like this explanation, and another scientist say, no, I like that explanation, and so forth. So there is a lot of still mysteries even in our bodies that we still do not fully understand, and not all theories are equally accepted. Okay, so next we will look with you at the structural levels of the matter, so to say, matter and the body. So let's say our body, the fundamental functional and structural unit of the body is cell. Okay, the foundational structural unit of the matter is atom. Okay, as I said, the foundational level, the foundational structural and functional unit of the body is cell. Now, we made from billions and billions of different cells, and some cells actually have a similar function. They have a similar function, and so you can actually classify different cells together, and those cells that have performed the similar functions, they form the same tissue. For example, we have nervous tissue, and the nervous tissue is made up of 5 different types of cells. You have the neurons, you have astrocytes, you have ependymal cells, and so forth. So all of them, even though they're not exactly the same, but they perform the similar function. And that function is to provide the function of the nervous system. Okay, so you have the also muscles. You have 3 types of muscles, right? You have the skeletal muscles, you have smooth muscles, you have cardiac muscles, and they are not exactly the same, but they're all muscles, right? So they form muscular tissue, and so forth. So I'm not going to go right now over all the tissues, but you got the point that the cells, similar cells, they form tissues. Okay, and then it requires at least 2 tissues. It takes at least 2 tissues to form an organ. So organs, what organs do you know? Well, we know, for example, bone. Bone is actually an organ. Every bone in your body is an organ. And then, liver, lungs, heart, they are made from several tissues. They're innervated, they are vascularized, they have muscle in it, right? They may have lining, which will form the epithelial tissue. So at least 2 tissues will form an organ. And then organs together, they form systems. So, for example, what organ systems do you know? Well, for example, your respiratory system. Respiratory system is made of lungs, made from bronchi, bronchioles, and so forth. Okay, so there are multiple organs. With digestive system, you have intestines, you have stomach, you have esophagus, mouth. So, and certain organs are actually shared between systems. For example, respiratory system shares certain organs with the digestive system. Okay, like mouth and pharynx. And we come to 12 systems that we have. Some actually classified just as the 11th system, but that's because of the lymphatic and the immune system. But other textbooks, they have 12 systems, whereas so not every textbook have the same classifications, but basically we have with you 12 systems. So if you will look at this picture here that you see on the screen in your textbook, that's the organ systems that we have. Now, I actually would encourage you to remember this, to memorize these systems. So there is a way to memorize it that is fairly simple. Now, here is the blank slide that I will try to actually show you how you can remember all those organ systems without kind of drilling and trying to just to memorize them randomly or without actually any logic. And the way to remember them, the way I can suggest it to you, of course you can memorize them in any way you want to, but there will be just more chances that you will miss something. And so the way that I would suggest to you is just imagine how God was creating the body. So we'll go from outside, right? Inside. So let's first make the bulk of Adam. And the bulk is what? Is the skin, right? On the outside, the skin is the integumentary system. So first, integumentary. Then what's below skin is the muscular system, right? And skeletal system. So now we have with you what's, so to say, the bulk. We have the form, right? But now this form needs what? It needs nutrients, right? It needs nutrients. It needs oxygen. So let's provide it, let's fuel it up. So which system you would say that brings the nutrients? Well, how about cardiovascular system? And then how about respiratory system? And digestive system. So now we already have the bulk, we have the form, and now we have actually all the nutrients already coming to the body. Now, what are we missing? Well, we are missing control, right? So right now, he is basically have no way to control the body. So what are the systems that are responsible for the control? Is the nervous system and endocrine system. And endocrine system. Okay, now we have the body, we have already all the nutrients are coming to it. We have already control even, but what are we missing? We're missing protection, right? Of course, in the Garden of Eden, Adam didn't need it, but God already put in him, foreseen what is going to happen, the system, the immune system, right? Immune system and lymphatic system. And lymphatic system. Oh, wow. So we already have pretty much everything. Now what we're missing is the system for the removal of the wastes. And there's the urinary system. Urinary system. Okay. And now, last but not least, is reproductive system. So this is a simple way that you can actually follow in the logic. You never have to memorize it. You just follow the logic and you will see how beautiful it's all just falls in one piece, just one from another. And as I said, you can just try for yourself. If you think, I don't need the system, I can just recall everything. Well, I give you 90% chances that you will miss at least one system if you will try to do that. Okay, but the system is always really makes you feel confident. You will remember it, because the logic, your mind will cooperate with you. See, because you have to program yourself. It's just how you program yourself. That's what your brain is going to generate to you, back to you. Okay, so I really encourage you to do that, and so that the whole body would be like one piece. And so you would hold the information like a ball in your hand. All right, next is, of course, we need to navigate throughout the body. And to navigate, we have to come up with a compass. So, north, south, east, west. That's to navigate in space. But to navigate around the body, we have to come up with what's called anatomical position. So here you see this lady. She is in anatomical position. So what is it? So you can see she stands upright, her feet slightly apart. She looks straight in front of herself. Her hands are turned with the palms forward. So this is the anatomical position. So this is the position in the body, as you can say, erect with arms at the sides and palms turned forward. The opposite of the anatomical position is the fetal position. Fetal position is when, as you know, the fetus in the uterus has the knees pulled. It's where the almost every joint is in a flexed position. So, and once we agreed with you on anatomical position, we can now look with you at the directions. Very important aspect, which many of them you already know, because when you were going through the anatomy class, you already dealt a lot with this direction, so we'll just refresh them. So superior means toward the head, inferior toward the feet, anterior is the front, posterior back, same as ventral and dorsal in humans. Then we have medial and lateral, medial toward the midline, lateral away from midline, proximal and distal. These are a little bit more complicated because proximal and distal refer to the nearest point of origin of a structure or nearest to the trunk. Okay, so usually proximal and distal refers to the upper and lower limbs, but not only. When we will be studying with your kidneys, we'll see the proximal convoluted tubule, distal convoluted tubule, because in the nephron, which is what's called is the functional unit. It's called parenchyma, which we will talk about this a little later. But the nephron has its beginning, and from that beginning, from what's called Bowman's capsule, you have already proximal and the distal convoluted tubules come out. So not only you can navigate and describe the your forearm and arm and the wrist and the elbow, but you can also navigate in terms of the internal organs depending on where is the beginning. Okay, so it's a fairly convenient term, proximal and distal. And then you have superficial, means closer to the surface, and deep, further away from the surface. For example, muscles are deep to the skin, right? Muscles are deep to the skin because they're below. And so proximal and distal, you have your wrist is distal to the elbow because it's further from the trunk. And then you have medial and lateral. Nose is medial to the ears. Anterior and posterior, for example, again, let's say the eyes are, or nose is anterior to the eyes, anterior to the eyes. And then superior, inferior. Head is superior to the chest. There is another term that is used that is not here, but it's caudate and cephalad. Cephalad and caudate. I'll just write it here. Caudate and cephalad. Caudate means toward the head, and caudate, let me write it down for you, is strictly speaking toward the tail, toward the tail. So just two more terms I'll write here is the cephalad and caudate. Caudate means toward the tail, literally toward tail, and this is toward head. Okay, so this is an important directional term also that refer to the also directions. So cephalad means toward the head. You can also set anterior means toward the front, or posterior means toward the back. You can say mediad toward the middle, lateral toward the side. But you don't say superior or inferior. That's why you don't say superior. Actually, you say cephalad or caudate. Okay.
Are these terms that end with the ad, like a Latin root or something like that, or just in the medical terminology or scientific?
No, this is only you can find as a medical term. In the everyday vocabulary, you don't use the terms superior or you don't use it for, cephalad or caudate. These are the, you will just use the word superior or toward the head, toward the feet. See, that's what you will say. But so basically you'll just have to, get used to seeing them, how they're used in the different situations, because head, as I said, is superior to the chest, right? Even though here they are saying that superior means toward the head, but actually there is a special term that is reserved for that. And as I said, what is that term? Cephalad. Cephalad is, strictly speaking, the term toward the head. And toward the feet would be caudate, toward the feet. But they are somewhat interchangeable. And in some situations, you can get by with just saying superior, inferior. But remember that, strictly speaking, toward is ad, as the suffix that is added after the word root, the ad. So you have, actually, after the prefix. These words, they don't have word root. A super is the prefix, ior is actually suffix. So you have ior and super, they make this suffix that ior actually pertaining to. Okay, ior suffix means pertaining to, super means above, infer means below, the prefix. But ad, it means toward. So you can say cephalad, caudad, there is no term superior, though you would think that you can make up a term. But unfortunately, when it comes to medical terminology, even though you have the word roots, prefixes, suffixes, but you're very limited in what you actually make yourself, because all the medical terms already made for you. And there are certain terms which you simply cannot put together, certain what's called word elements. You can't put them together. So these suffixes, prefixes, roots, word roots, those are word elements. And the scientists already thought for us here. But we'll see more examples in the future how to use that. All right. Let's look with you at the planes. There are 3 planes. So as you can see on this picture, you have the first one you see is the transverse plane. Here is the horizontal plane. The transverse plane is the horizontal plane. So the transverse plane divides the body, the upper and lower part of the body. Okay, so it divides on what is superior and inferior parts, superior and inferior parts. That's the transverse plane. Then we have the plane that divides the body into right and left part. That's the sagittal plane. Sagittal plane. So here you see the sagittal plane. So it divides your right ear from left ear. And so the sagittal plane, there is a special plane that is called mid-sagittal plane. As you can imagine, it goes exactly through the middle of your body. All right? Through the middle of the nose. Okay? The middle of the, exactly through the middle, and divides the body equally through the right, to the right and left half. So it divides the body on the right, to the right and left halves. So that's your mid-sagittal. But as I said, there is not only mid-sagittal, but there are many sagittal planes that can slice the body anywhere between from the right and left parts of the body. Okay, so that's the part that divides the body into right and left halves, right and left parts. And finally, we have frontal plane. The frontal plane divides the front from back, anterior from posterior, ventral from dorsal. Okay, so this is your frontal plane, or another name for it is coronal plane. Coronal plane is like a corona, right? Divides the front from back. So transverse is the horizontal plane, and then you have the sagittal plane as well, which divides the body into the right and left parts. Okay, let's now look with you at the cavities. So there are 2 largest cavities in the body, and that's ventral and dorsal. Here is the picture of ventral and dorsal cavity. So here's the ventral cavity. What does the ventral cavity consist of? It consists of the thoracic cavity and the abdominopelvic cavity. Thoracic cavity and abdominopelvic cavity. Then thoracic cavity is further divided into 2 pleural cavities and mediastinum. Mediastinum contains heart, and a pleural cavity contains lungs. So you have right and left pleural cavities. Okay, and here is the abdominopelvic cavity. So there's abdominal area here and the pelvic cavity. Okay, so abdominal and pelvic. So you have abdominopelvic cavity. And of course, diaphragm is the one that separates these 2 cavities. Okay, and the second largest cavity is the dorsal cavity. So dorsal cavity houses brain and the spinal cord. So these are two major divisions, ventral and dorsal cavities. As we said, ventral, we just described, consists of thoracic and abdominopelvic. Dorsal consists of cranial and spinal cavity. So cranial cavity contains what? Brain, and the spinal cavity contains what? Spinal cord. Okay? Spinal cord. And of course, these cavities, they contain multiple organs. For example, abdominal contains stomach, intestines, liver, gallbladder, and so forth. Pelvic cavity contains reproductive organs, urinary bladder, lower part of the intestine, meaning of the colon. Okay? So we need also to kind of get more specific at how we can better navigate and point to different parts of this, let's say, abdominopelvic cavity. So, as you can see, that the one of the ways to divide the abdominopelvic cavity is by the quadrants. So you have right upper, left upper, right lower, left lower quadrants. Okay, and but let's say we want to be even more specific than that, and we want to divide it. Then we can divide it into 9 actually regions. Now there is a way also for you to remember them, kind of following certain logic instead of trying to recall them randomly. So I like to start with umbilical region. Why? Because it's kind of the easiest to remember, umbilicus. And umbilicus, the central region, is called umbilical region. Umbilical region. Then you can, and then depends on your preferences, because gastric, the word gastro is the medical term. Gastro is actually combining form. Gaster is the word root for the stomach. So gaster is the word root for the stomach. That's why you heard about medical term gastritis, right? Inflammation of the stomach, gastritis. So this is the stomach. Here's the stomach. And so you have epigastric. Epi is the prefix for above, above. And hypo means below. So you have epigastric region that is above the stomach, and hypogastric region below the stomach. So hypo means below, gaster means stomach, and ik means pertaining to. That's the suffix that defines the belonging to something. So belonging to below stomach, epigastric, belonging to above the stomach. Okay. Then you have right and left lumbar region. Now that's the lumbar spine. What does the lumbar mean? Lumbar is the region in the your vertebral column that consists of 5 vertebrae. Vertebrum is the singular form. Vertebrae is the plural. So you have 7 vertebrae in the cervical spine. Then you have 12 in the thoracic region, and 5 in the lumbar region. So that's your waist area, right? Waist area. Those are the largest vertebrae that basically hold the weight of the thorax, of the trunk, of the whole body, of the upper body. Next is, so there's a right and left lumbar region. So they correspond to the lumbar vertebra. Next is the right and left iliac regions, which is the inguinal regions, and the iliac, the name of this region is taken after the flaring part of the coxal bones. There's the pelvic bones. Another name for pelvic bones is coxal bones. The iliac bone is the largest flaring bone of the pelvis. Okay, so it's one of the three bones of the pelvis, iliac bone, which is actually individual bone in the fetus, but then gradually the bones of the pelvis, they fuse together and become less and less mobile. So that's your right and left iliac region, or you can call it inguinal, right and left inguinal region. Inguinal is another name for the groin region. So in the lay term, we call it groin, or inguinal region is the medical term. And then as we look with you up here, we have hypochondriac, right and left hypochondriac. The chondr here is the word root. Chondr means cartilage. Hypo, you already know, prefix below, iac, pertaining to. So pertaining to, below cartilage, pertaining to, below cartilage. So where's the cartilage here? Well, we know that the ribs from 8th through 10th, they share the cartilage of the 7th rib. So all this area is kind of below these cartilages that are joining the ribs from 7th through 10th to the sternum. Not to be confused with the hypochondriac. Hypochondriac is another term for, actually it's a medical condition. When somebody is hypochondriac, that means they tend to exaggerate they tend to exaggerate their condition, their real condition. So hypochondriac, so that means they actually think they are more sick than they actually are. There's the hypochondriac. Is the mental condition when some people, they think that they're sick when in reality they're not. All right, so these are the 9 regions, and each one contains, its own organs, which is important and convenient to navigate. Let's get back to this picture. And so as you can see, we have these lines here, right? So you may wonder, where's these lines are drawn? What is the way that these lines are drawn? Well, this one is this. Okay, let's look first at the vertical lines. The vertical lines, they are drawn, as you can see here, across the mid-clavicular line. So this is the clavicle, mid-clavicular line, and goes down. This is your right and left planes, the sagittal planes, of course, these are already sagittal planes. And then we have 2 transverse planes. One of them is at the level of the 10th cartilage, 10th thoracic cartilage. And this one is goes on the top of the hip bone, pelvic bone here. Okay. All right. So let's look now at the dorsal cavity. Dorsal cavity contains brain and spinal cord. You already know that it's divided into cranial and spinal. So here's how the body is divided. Another way to divide the body is by two major regions, the appendicular and the axial. The axial and appendicular regions. So you have the axial skeleton, to which all the rest of the body is appended to. So you have 80 axial bones, 126 appendicular bones, and so they're here in different colors. You have the skull, ribs, and vertebrum form the axial skeleton, and then the rest of the bones, they form the appendicular skeleton. So as you can see that your upper and lower limbs, they're connected to the axial skeleton via girdles. You have shoulder girdle and pelvic girdle. So the shoulder girdle made from clavicular bone and the shoulder blade, scapula, and here the pelvic bones form the pelvic girdle. So you see front and back.
I have a question.
Uh-huh.
Why the difference between the axial skeleton and appendicular skeleton? I see the colors, but what makes it different to be axial versus appendicular?
All right. The appendicular, the axial skeleton here I'm showing here is kind of light violet color, is the one that serves as the core, is the one which holds everything else. You know, you have, when you build a house, you have frame, right? And then the frame, on that frame, you hang the walls, roof, and so forth. So this is basically your frame, is the axial skeleton. And so everything else is attached to it. Your arms and your legs, okay? They're attached to the skeleton, actually. Okay. So here is, you have the recap. The axial region is made of head, neck, and torso or trunk. An appendicular region consists of upper and lower extremities. Okay, of course, with the girdles. Girdles are part of the appendicular region. So here's another picture of the same thing. So you can see the skull. Skull is another name for all the bones of the head. Skull means all the bones of the head. So, and then you have the vertebral column with the ribs. And here you have the appendicular skeleton. See the girdles? We'll look more, of course, into details once we get to the skeletal system. It will become more clear there. We'll look into that in more details. I don't want to stop on it for too long right now. It's kind of an overview anyway. So let's look right now at the balance of body function. There is a fundamental idea. There is a fundamental term that we use when it comes to the balance. Balance is a kind of a lay term. There is a word, homeostasis. You see it here, right? Homeostasis. Stasis means state, and homeo means equal. It's an equal state, literally. Literal state or relative constancy of internal environment. So what is it talking about? Well, you know, we have body temperature, right? We have acidity, of the blood. We have concentration of different gases in the blood. What else? We have levels of different hormones, different chemicals in our body, and all of them are within specific range. Within specific range. For example, our acidity is between 7.35 and 7.45. Okay, so we're slightly alkaline. Our blood is slightly alkaline. And if the body will detect that there is a deviation from it, then it will do its best to return back to the previous condition, the normal condition. It will restore what's called homeostasis. It will restore the homeostasis. And our survival depends on it. Our survival depends on it. Now, it's interesting that this range of the set points in our body, set points for body temperature that you can comfortably tolerate, for the, let's say, acidity in the blood, for the levels of different chemicals in the blood, they actually change throughout the lifetime. For example, when we are young, we may be able to tolerate temperature better than we are getting older, right? So when we're getting older, we're trying to kind of stay warmer, or sometimes we get too hot when everybody else feels normal. So, and that's because the chemicals in the body, which we're going to look more with you in the future, what actually defines the changes in the homeostasis, in the shift of those set points in our organism, that under influence of different hormones, as the hormones change, the set points change, and our range of the comfortable zone changes, right? So another descriptive term for homeostasis, you may say it's a comfortable zone where your body is comfortable. You know, feel comfortable, you can normally perform all the physiologic functions, and it doesn't like when you go outside of those set points. So, and the body is using for that what's called feedback loops, either negative or positive. Let's look at that. So what does the negative feedback mean? Negative means once the change was detected, your body is trying to return back. Basically, it's trying to negate, or it's trying to abort, so to say, the change and return back to where it was. Whereas the positive feedback loop, as you can see here, positive feedback loop is exactly the opposite. Positive feedback loop actually encourages and enhances the change. Okay, and the classic example would be here, when we are getting, this is the negative feedback loop. As you can see, they bring the parallel with your AC or HVAC at home. I don't know what system you have, but the thermostat and the temperature regulating devices, once they detect the change in the temperature, the sensor detects it. So the thermostat will send the command to the furnace, and it will start raising the temperature, right? Produce the hot air. Same thing in the body. So you have disturbance, hypothermia. Hypothermia means the body begins to shiver, the body temperature begins to go down. So it's detected by your cold receptors. It's sent to the brain. Your hypothalamus is the organ that is responsible for the temperature regulation. Hypothalamus sends the command to the skeletal muscles, and the skeletal muscles begin to contract reflexively. So that's what we call shivering. And as a result of those contractions, involuntary contractions, the body warms up. Okay. So here's the classic example of the positive feedback loop, because not every change in the body is bad. Certain changes the body actually wants to enhance. It wants to encourage them. And for example, during the delivery, during the birth, as the contractions begin, the last thing you want to happen is for those contractions to what? Stop, right? That would be the last thing you want to have. In fact, you want those contractions to get as strong as they can so that it would all go happy within 30 minutes, right? So, and there's a mechanism for that built in. There's a hormone called oxytocin that is released from your pituitary gland. Now, we may not be familiar right now with all the regions in the brain, but there is a gland called pituitary gland that releases a special hormone. It's called oxytocin that initiates the contraction of the uterus. So the stronger contractions will eventually push the baby through it. I'm tempted to talk with you a little more about what to do if the contractions stop, but I have to control myself. We'll talk about that in the future. This is not right now the class to talk about it. All right. So, and there are other examples of the positive and negative feedback loops. So, for example, if I have a cut and I have inflammation, I actually want that inflammation at first to increase. And so you'll have the cytokines, there are chemicals that will attract your white blood cells to come, because I need to take care of bacteria that got into my cut. I need to take care of the now restoration of the tissues. So at first you want that positive response. You want to enhance the inflammation. But then as the repair took place, then you want actually everything to return back to initial level. Same with the sugar. If the sugar goes high, you want actually that sugar to low down. And so the insulin will increase in response to the sugar to bring that sugar under control, to remove it from the blood. So that's the example. Here you can see in comparison, release of insulin in itself does not cause more insulin to be released, but the amount of glucose stimulates the insulin release. So different responses of the body, they can be looked upon in a different way. For example, sometimes this is a mixture of positive and negative feedback often in the body. So it's not like a simple positive or negative feedback. So it can start as a positive, but then it goes into negative feedback. So there is a blend of them. And so, as I mentioned, that this homeostasis changes throughout our lifespan. Okay, so this was the first chapter